Alright, hello everyone. We will today learn about the experiment that has been done in our lab class. I have done a video on this previously, but the difference from before is that there will be a specific thickness on our laminar pipe flow from now on. So that laminar pipe for a flow through a laminar pipe, we have to specify a thickness. We need to do some changes in the geometry. So I will show you the geometry changes and also the flow conditions. There will be some changes in there as well, as a teacher, as a professor mentioned today. So I'll be starting with the geometry first. So let's go to the geometry, drag it here, right click on the geometry and new design modeler geometry. Now you can choose anything over here: space claim, discovery, or design modeler. I am choosing design modeler as an default. So here is our interface here, and now we will start generating the geometry. So I am drawing the sketches on the XY plane. You can choose any of the plane, it's your wish. So click the plane and go for new sketch and go to sketching mode, and let's create a circle. And for a better view, go to look at, so that you will see a perpendicular view of this XY plane. Zoom it a bit, and as our dimensions are in millimeters or meters, you have to change the units first to meters or millimeter, either you can choose. Just don't keep it in foot or inch. Alright, so my bad, escape. So choose this center, and we are creating a circle. Choose this center until you see the C or P. You have to see the C. You can see C as at the center of the axis. So unless you see the C, do not select that point. So after you see the C, let us see actually, choose the circle and give it a dimension. Again, this dimension is based on what the dimension today our professor has mentioned, which is 0.075. It's a small circle. So I told, okay, so there is a mistake between while we are choosing the center of the circle. So I will do it again. Let's go for undo. It should be open. It should be it should be okay. Now go for the draw again and select a circle. As I mentioned, you should see the center as P, not C. That was my mistake. I'm sorry about that, but always make sure that you have to select the center. Until you see the letter P, you have to select the right center. So now I'm giving dimension of the center to this circle. Dimension, I'm choosing a radius. So the circle radius has to be 0.075. This is what the dimension our professor has mentioned today. Next, what we will do is we will sketch the inner surface as well in the same sketch. So go to sketching mode again, and okay, just go to draw and go to a circle and choose P and go to this point and give it a dimension of radius again. Select this point, drag it a bit, and give this radius as 0.073, as our thickness for the pipe was given as only 2 millimeter. So this is the sketch for the intersection, or the you can see the cross section of the pipe. So our sketching is done. Now go to the modeling and just extrude. And I have to mention that you do not need to create generate again and again for sketching. You have to create generate for any other parameters you are choosing here. So I didn't use generate for the sketching. I just will be using generate for the other options I will choose, like extrude. I'm giving a depth of only 0.75 as similarly mentioned from a professor, and you should see a right length of pipe. And make sure that the operation is in add material and none of add frozen or cut material, but add material. Add frozen, you will choose it when you want to analyze the simulation outside the material you are creating. But here we want to do a simulation of flow inside the pipe, so use the add material and give it. So already every parameter is here. Okay, now click generate and you should see a pipe. Now the main difference of the flow analysis, as I have done before in my previous videos, as laminar pipe flow through a pipe. So the main difference would be the thickness here. So the flow has to be go through this cross section of this pipe. So as in this pipe there is nothing in here, so I have to make something in this cross section of this pipe, or inside the pipe in simpler words. So as there is nothing inside this pipe, I have to make something here. So for that I will fill this pipe, and design model has a specific option for that as well. So go to tools and you should see a fill option here, and choose bicavity, and the face should be this face. You should make sure that the whole face has been selected, and apply, and you should generate. And now you should see two bodies, right? And there's another body inside this pipe. It's just very transparent, you won't be able to see it, but you should see a two bodies here, right? Previously I have seen here only one part and one body. So before going any further, I have to make it make one part and two bodies from here. The main thing is you have to always make sure that there is only one part in your geometry. I have two part and two bodies. I must make sure that I have only one part. Why you should do it? You should do it because if you do not have if you have multiple parts, the meshing would be discontinuous. You have to select mesh for different parts by yourself. I am not going to do that, so I will be creating one part from these two parts. Bodies is okay, you can have multiple bodies, 2 bodies, 3 bodies, 5 bodies, as many bodies you have here. That doesn't matter. What matters is just the parts number. So alright, so to do that, select this and select this and form a new part. And if you want, change the name of this this here to fluid, and obviously generate. Alright, so the last thing in this geometry is to do a name selection. Now name selection is important because it will be for your own comfort, because while we will be solving things, we will be solving this flow analysis, we have to make sure that this surface of the pipe act as inlet for the flow, and this surface of the pipe act as an outlet for the flow. So to ease the selection of the surfaces, we have to name this. So to name, now you should see a name selection here and give the name to inlet, and similarly, and before going any further, go generate, and similarly name this surface as outlet. Make sure the surface selected here, name selection is outlet, and generate. And finally this should be act as your wall. So you can do one thing. Alright, so you can it will be okay. Just make sure the surface option is selected and select this as the wall, and name selection and wall. You can also name this space as well, but you won't be needing it. Only selecting this as wall will be okay. Alright, so this is all the thing we have to do in the geometry section here. So I will be moving into meshing now. Go to the workbench. Before going to the workbench, save this file, save project. I am saving it the desktop, so it's easier to select. Okay, I have to give a file name, so let's say flow circular pipe. 1 and save. Now we will be moving on to the meshing. Before going that, save here as well to make sure everything is saved. So choose meshing, drag it in here and double click on the mesh, and you should see a starting meshing option here. Not an option, just a message. Alright, so this is our pipe here. So before going any further, select the mesh first and change it to CFD, as this is a CFD experiment, not an mechanical experiment. So next thing I will be doing that, giving it a global meshing. Global meshing means you have to select a perfect shape that will be applied for the whole body. Right click on the mesh, insert, method. Okay, now select the whole body, select all and apply. Should say two bodies here, not one body but two bodies, and change this method to tetrahedron. You can also use hexahedron as well, but you have to remember that hexahedron shapes will give you a more finer and proper results if you are doing if you are meshing a very complex geometry. As a laminar pipe flow, a laminar pipe, or a Y-shaped bent pipe, these are very simple shapes. So any shape, any method you choose from here is okay. So I am choosing this tetrahedron, and you can see sweep, anything you can use. You can even use the automatic one, it is the default one, but I am using tetrahedron. Alright, so generate. And the meshing is done. You can see this is a very rough mesh, so I'll be make a finer mesh on this wall now. Now let's give a body sizing. While giving a body sizing, it will be after the whole body, so make sure that you select the whole body while sizing. Go to sizing and select all, while keeping in mind that this body part is selected, not solid, not surface, not point, not edge, only this body part. Alright, now apply it. You should see again two bodies, and change the element size to 0.01. now this is not, I have something fixed as 0.01. you can use 0.0001 as well. You can see you can use 0.001 as well, but that will be costing so much time and that it will be not worth it. So I have tested before it that this value is it will consume very less time and it will be acceptable mesh. So generate. And let's look at the mesh, and it should be okay. It's a very good quality mesh. Now what we need to apply here is to give a finer mesh on the faces, because this face here and this face here is a particular interest of ours, because the flow will go through this and go out of this face. So choose this face and also select this face and right click on it, go to insert, sizing. You can also go from here and then sizing, it's all okay, but you should see two faces on the geometry here. And the element size, let's change it to a finer value than the body. I had given 0.01 to the body. Now let's give a finer value on the surfaces as well. So let's select a value less than 0.01, so 0.005 and generate. Let's look at the mesh, and we should see a very fine mesh on the face. The last thing I'll be doing is applying an inflation on this geometry. Now keep in mind that these steps I am going through is not necessary. You can also get the same result with the very bad quality mesh, because this is a very simple geometry. But it is a good practice to always make your mesh very fine and very specific to the flow. And say right click on the mesh, insert, again go to the inflation. Now inflation, you know what inflation means. Inflation means I have told before in my videos as well, Inflation means basically you have to tell ANSYS that this is our boundary. This is our boundary, not the whole geometry, but this is our only boundary, and flow should not cross through this. So inflation is just fixing what the boundary is. And for a geometry selection, select this body, the inside body, and apply. And for the boundary, the flow will be going through this, so the face should be the face. All right, let's hide this face and see if the hide body. Go to inflation again and choose this face. Let's see if it acts or not. Now generate. If there is no problem in the meshing, we will be going through. And now show this body, and now let's look at the mesh. Let's zoom it a bit to see if the the inflation layer has been applied properly. Now if I want to increase this layer, just go to the inflation option and increase this to 10, and also change this default transition ratio to 0.5. And let's generate again. I'm just finding the inflation method as well. It will create a better mesh quality here. You can see there are more layers now than before, and this should be the meshing. The mesh look alright, the mesh looks fine. So this is what our meshing is, and now we will move into the solution phase. Now we will be solving the fluent, so locate fluent and drag it here, and you see the moment I drag fluent in this box, you are seeing an update option. This is important because mesh has to create an .msh file or simply a mesh file for the fluent to solve. Before putting the fluent here, mesh did not create any file for the fluent, so I had to manually create it. So just right click on the mesh and update, and you should see a tick mark here, and the tick mark is okay, and go to setup now. And as before, choose double precision and give 4 cores. If you have 4 cores in your processor, then choose 4, and if you have larger than this, choose that value, but 4 is enough. So start. Sorry, my bad. Okay, so this is our pipe. So before going on to anything, I have to show you something about Reynolds number. I have to make you understand some part about it. Just let's go to the Chrome, go to and search for, let's say I have there is a proper Reynolds number calculator. So as we know that close to 100, the flow, if the Reynolds number is close to 100, the flow is supposed to be laminar. In our conditions, we know that basically we will be using the water as a fluid through the pipe. So if the velocity condition and the fluid density and viscosity condition, it matches to the Reynolds number value of 100, it should be okay. But if it crosses this, it will be not okay. Let me show you what I mean by that. Fluid velocity, as our professor has also mentioned, this value is 2 meter per second, and characteristic linear dimension is it has to be the length of the pipe, which is 0.75, and the substance we should choose water, let's say at 10 degrees Celsius. I don't see a 25 degree, so let's choose just this, and you should see the Reynolds number is very high and the flow is probably turbulent. So I cannot use the default water conditions. in the ANSYS as well. I have to manually select the dynamic viscosity and density and whatever not. So the density is fixed, I should not change it, but what I can change is the dynamic viscosity. If I, let's keep it custom and give it a fluid density of 998, which is basically of water density, and give it a dynamic viscosity of 15, and you should see Reynolds number close to 99.8, which is very close to 100, and you should see the flow is probably laminar. But if I had choose the default condition of the very low viscosity of water at 10 degrees Celsius, you should see a very high Reynolds number and the flow is probably turbulent. So make sure that you should manually override the viscosity value in the ANSYS as well. Otherwise your flow will be turbulent. Even if you give the laminar condition, it will not work. Your solution will not show proper results. So go to the fluid, and now the generals are all okay. Now we have to choose pressure based, because our velocity, our density will not change in this condition, in this flow. If our density would change, that would mean we are dealing with a compressible flow, and then we will choose the density based option. But now, for now, we should use pressure based conditions, and the time is steady as well. That means the velocity will be steady along the time. That's it. So go to the materials option. Before going to the materials, go to the models actually, and choose viscous and go to laminar, as this is a laminar pipe flow analysis. Now let me clear one thing. If you had choose laminar here but kept the default conditions of water, you should see this value, ANSYS would get this value, but it will also say that you have given a laminar condition, and at that point the flow analysis will not be okay. It will give you faulty results. So make sure if you choose laminar, you have to override the normal conditions of the water as well. So go to materials now and go to air, double click on the air, and should see create an edit materials option, and change this density to 998, let's say. And as we have calculated, if the viscosity is close to 15, the laminar the Reynolds number will close to be 100. Otherwise the viscosity will override to the default value of water, and it will give a very high Reynolds number, and which will not will match with our models, which is laminar pipe flow. So change and create, and before doing that, change this name to water actually, so it will be more meaningful. And now change and create again, and yes, and close. Alright, so next go to the boundary conditions, and for inlet, as we have mentioned before, the inlet velocity has been given by a professor. It is 2 meter per second. So change it to 2 and give the direction as you can see the coordinate files, coordinate system here. The z in this direction, that means the z in this direction, but the flow is going to the negative z direction. So the absolute value should be 2, but the flow direction should be -1, and the other direction there is no flow, so this should be 0. This is 0 from default, and apply and close it. Now go to the outlet option, and you should see a type as pressure outlet, and we will be giving the boundary condition at the outlet as 0 meter per second. So 0 Pascal actually, sorry. So go to edit, and it is already 0, so do not have to change anything. So apply, close, and lastly go to the this part here and edit, and you should see, close it first, you should see a no slip condition. Yeah, you can see no slip condition as the shear condition, because unless you choose a no slip condition, the flow will not treat the inward surface of the pipe as a wall. So apply and close, and you should be all okay. The last thing is to initialize, and choose standard initialization and compute from inlet, and you should see a -2 here. If you see 2, then you have to change the reference values as well. Yes, I have to reference values as well to change this area, the area of this pipe. So I have calculated the area for this pipe. If the diameter is, if the radius is 0.075 or 0.073 actually, but let me show you how I do it. Let's choose the calculator, and the area for condition for a circular pipe is pi r square, simply that. So 3.1416 into r square. R is here is just 0.073, the inlet one, so 0.073 square. 0.5329. If I had chose let's say 3.1416 into my bad, I have to clear it all. 3.1416 into 0.075 whole square. Alright, so this would be the area, but choose the area that is for the inlet option, the inlet. So choose 3.1416 into the inside radius, which is 0.073 square. So this is pi r square. So it is 0.005329. So I'll be choosing that as an area, 0.05329. Check the value again. My bad, it's another 0 here. And change the density to 998. Change the length to 0.75. Change the velocity to 2 and viscosity to 15, as I have seen in the Reynolds calculator. You have to be 15 to make a laminar to make the laminar flow, and also compute from inlet. So all okay. So now go to the initialization option and compute from the inlet, and now initialize. So initialize has been done, and now go to the run calculations and change the iteration number to, let's say, 1000, and calculate. So you should see some graphs here. So I will let this iteration number run until I see a nice lines from all of these three lines. So let's see. Alright, so we have just calculated 60 or 50 iterations. Let it run a bit. As you can see, this is the console, and you should see the iteration number here that is running here. This is the remaining iteration number from 1000. Now you can see that almost 886 iteration number is still running, still running. So I should stop here. Okay, so if you see the mesh now, and should get the results, and to see the results, go to contours, go to new, and choose a new surface, go to plane. I'm making a new plane through this pipe actually. So YZ plane, this is the YZ plane, so this should be okay. And let's say create and close. Now choose plane 6, and let's see the contours of velocity, that because we are will be making the velocity contour, and save and display, and you should see a nice contour here. Alright, So let's see the parabolic shape here. So close this and go to vectors and choose inlet, outlet, and plane 6. No, plane 6 will not show the parabolic shape. Just let me show the inlet and outlet first, and increase this value to 20 to better see the arrows. Okay, this is way too much. Let me I see a problematic mesh here. Right, there's some issue here. You should not see this. Alright. Let me fix a thing here. Alright, before going anything, just let me show you the parabolic profile. So go to new surface, make a plane that will be perpendicular to the pipe. So choose the xy plane that will be perpendicular to the pipe and create and close, and only choose the plane 7 and save and display, and you should see the parabolic shape. It's the parabola you'll be looking for. And if you want another surface, let's say another plane, let's say the xy plane again, and give it a distance so that the flow will be some distance from this. So give a distance of, let's say, 0. Our length is 0.75, so make sure that the value is inside that range. So 0.5. Yeah, so create, and now choose this as well, and you will see the parabolic profiles, right? And you should see the inlet outlet as well. The only